Hello everyone, welcome to my YouTube channel. So today I am going to discuss about reentrant corners. Okay, so here we will see that what is reentrant corners, and when we go for analysis of structures, then what is the process to identify that your structure is reentrant, and in that case how you will analyze the structures. Okay, so firstly we will see that what is reentrant corner. So let us start. Okay, so see, suppose your structures shape, it means plan of the structures will be like this. Okay, if your plan of the building and any structures will be like this, and then suppose this length is L1. Okay, and see, this length is, we will take A. Okay, like that. This length is L2. Okay, and from here this length is, we are taking B. Okay, so there are some formula. Okay, suppose the formula is that if A, ratio of A by L1. Okay, if ratio of A by L1 is greater than 0.15. Okay, so we say that this structure is called reentrant. Okay, reentrant corners. Okay, okay, so if the plan of your structure will be like this. Okay, and then if the ratio of A by L1 means this length divided by this length is greater than 0.15, then we say that this structure is reentrant corners. Okay, so like that, if B by L2 is greater than 0.15, so same, it is called reentrant corners. Suppose this length is like suppose that 4 meter. Okay, and this length is 2 meter. So A by L means 2 divided by 4 means how much coming? It's coming 1 2. Okay, so when 2 divided by 1 must be 0.5. Okay, so in this case it is not a reentrant corners. Okay, so if your structure is more than 0.15 means 15%, so in that case we say that this structure is reentrant corners, like that. Okay, so this is the reentrant corners, how you will recognize your structure is reentrant or not. Okay, so if suppose your structure is reentrant, your plan of the building is reentrant corners, then what you will adopt when you go for the analysis. Okay, so let us start and see. If your plan of the building, if your plan of the building is reentrant okay reentrant corners, then have generally have to adopt. Okay, what you will have to adopt in that case? We will have to adopt space x, spec y and spec z. Okay, means dynamic analysis of three dimensional you will have to adopt it. What is space x? Space x, spec y and spec z is a dynamic analysis. Okay, so in this case you will have to adopt these three. You will have to perform space x dynamic analysis, spec y and spec z. In this case, if your plan of the building is reentrant corners, in that case you will have to apply space x, spec y and spec z. Means this is the dynamic analysis of three dimensional. Okay, so this is your reentrant corners. I am just giving one more example to understand best. Second example, let us see. Suppose your plan will be like this. Just taking this one. Okay, your plan will be like this. Okay, okay, suppose your plan will be like this. Okay, and suppose this length is a, this length is also a, this length is also a, and this length is also a. Okay, and total length, this is L. Suppose your plan will be like this. Okay, so first you will have to see that this plan is reentrant or not. Okay, so for that what will happen? Just take a. Okay, a means this length. Either you can take this length because all length will be same. So if a by L, L is this length, is greater than 0.15, means 15%, then you will have to say that this plan of the building is reentrant corners. So in this case also you will have to apply same. You will have, when you go for the analysis, then you have to apply space x, spec y and spec z. Means dynamic analysis of three dimensional you will have to adopt. Okay, so I hope you got it, what is reentrant corner, because it is very important. Some area you have been seen that some structures has been constructed like this type of plan. Okay, so in this case we generally adopted reentrant corners process and we generally adopted three-dimensional dynamic analysis. Normal structure, suppose that this is your structures. Okay, so in this case what we do is that we generally adopted only dynamic analysis in x direction, dynamic analysis is in y direction only. Okay, but in this case, in the case of reentrant corners, we have to apply three-dimensional dynamic analysis. Means spec z also we have to apply and check. Okay, so this is called reentrant corners. I hope you understood what is the meaning of reentrant corners and what is the process to calculate this plan is reentrant corners or not. If not, if suppose that this is your structure, this is your plan of the building, and if a by L1 is not greater than 0.15%, then this structure is not reentrant corners. So in that case there is no need to apply spec z, only have to apply space x and spec y. But if a by this length and this length is greater than 0.15, then we have to come to know that this structure is reentrant corners. In that case you have to apply spec z also. Okay, so I hope you got it, and if you like my channels then kindly share and subscribe. Thank you so much.